Hello, and thank you very much for joining us on the CloudKnit FM podcast. And we're talking about self service infrastructure and the complex environment and how to simplify those management. As you all know, the self service infrastructure platform continues to revolutionize the way we manage resources, addressing these modern challenges becoming integral by incorporating policy as code, governance and automation, network policies, access management, and GitOps practices. Organization can navigate the complexity of complex environment with confidence. The key lies in striking the right balance between agility and control, a harmony that ensures innovation flourish while maintaining the highest standard of security and compliance. And today, we're speaking again with our yesterday, a week ago guest, Adar Shah. And today we're learning about open source tool called CloudKnit. And I will let you know. Please be ready for some of the very wonderful feature around self-service infrastructure platform. So without any further delay, let me straight go to Adar Shah. But thank you very much for joining us on a back-to-back shows and give us some cool intro of the project that you're actually developing behind the scene.
Yeah, thank you. Thanks for the intro again. And yeah, I'm glad to be back here again. And now talking about the open source solution we have, CloudKnit. Do you want to just jump in, or I can start by giving the context of why we build, maybe, and then go into some demo and stuff. So yeah, as mentioned, like, it's an open source solution. I'm gonna actually share my screen and show you the GitHub repo and kind of go from there. So let me figure this out. Let's see. Cool. Let me know when you see the screen.
Yes, I can see it perfectly well. And in audience, if you don't able to see it, please comment in the chat section. And now you can continue, others.
Awesome. All right. Yeah. So as you mentioned, like, it's a self-service management of complex cloud environments. We have it open source. It's Apache v2 license. And what problem we are solving is there are a lot of great tools available for automation today, right? You have tools like Pulumi, Terraform, Helm, Argo, AWS CDK, and there are so many other great tools that allow you to automate your infrastructure, your application deployments. The problem, though, is as you start scaling and your environments get more and more complex, the management of those are not as easy. So what people do is people take all these various tools and they build stuff on top of that, right? And what they do is they try to achieve advanced use cases, right? For example, if you want to do Brew Green deployments, or if you want to do ephemeral environments where you want to spin up environments and then spin them down where you don't need it. Getting to all of that use cases is very difficult. These tools are great at automating what I call it as various components. So let me actually pull up an environment in CloudKnit and then kind of talk through. So here's a typical environment in AWS, right? So you have your networking, your EC2 instance, let's say, for something, and you have your Kubernetes cluster, your apps, RDS database, SageMaker. All of that together is something that is meaningful to you, right? Because it is your demo environment, right? You need to run everything together to run some business application. To do this with existing tooling, you have to do a lot of various things. And some of the examples are, if you're using some kind of pipelining tool to run your infrastructure as code or deploy your Helm charts, you need to connect these various components. And I have seen teams write thousands of lines of pipeline code to provision, let's say, 3 or 4 environments. And managing those dependencies or do some kind of tight coupling makes it very difficult for you to manage these environments, right? So that's why I have seen companies spend, like, millions of dollars, right? Up to $3 to $5 million to build a platform to manage on top of all these existing automation tool. And then they spend millions of dollars maintaining it every year, right? Because you still need to add features and stuff like that. So that's what we are looking to solve. We are basically making management of complex environments really easy. And also, we are providing all these advanced use cases that help you gain competitive advantage.
Yes, absolutely, absolutely. I think one of the question and one of the pain point currently the enterprises and a lot of the open source communities and everybody's talking about these days is because we have even previously without the advent of the Kubernetes, we use Terraform to spin up spin up infrastructure and then start consuming it. And the AWS, Azure, GCP will give you layer by layer, pay as a service model. Like if you want to need your networking, storage, and other pieces of the infrastructure, you can bring those up by having an infrastructure as code things. But having the advent of Kubernetes, there are two different phases now: the cloud
Yeah.
and the cloud native. And sometimes these are overlapping. Some the cloud native functionality still exists in the cloud, but sometimes it doesn't. Like GitOps is solely around Kubernetes as of today. It's not much out of the Kubernetes space. So today is really a need of self-servicing infrastructure platform. So the question number one is like if somebody is actually using CloudNet to spin up the infrastructure, like how the development workflow look like?
Yeah, so CloudKnit is also GitOps based, right? I can actually just jump into a demo and kind of show the workflow, maybe. So let's. I'll just start by showing the dashboard a little bit, and then kind of provision an environment. So we have a concept of groups, right? So you might have various teams, or you might be deploying your software to various customers. So you can group various environments, and you can see, like, here there is a payment team in this case, and they have a bunch of various environments. I'm going to click on that, and then you can see, okay, there are, what is it, like 13 environments they have, right? They have a bunch of dev environments, they have demo, production. So what I'm going to do now to show the workflow is actually start provisioning a brand new environment. So as you can see here, this environment, prod blue, is entirely destroyed, right? I brought it down half an hour ago, and I'm gonna go ahead and actually provision it. So let me go to my terminal. So here's my terminal. Here's the GitHub repo that has all the code, the configuration basically that I'm gonna make changes to deploy. So here are all my environments for my payment team, right? I'm gonna go to prod blue environment, the folder. We have a YAML format, which is a custom resource actually in Kubernetes, right? So it's a very straightforward format that allows you to define your environment. And we can go into it, the format itself in detail a bit later. But for now, what I'm going to do is I'm going to focus on these two lines. So as you can see, this teardown flag says true, which means the environment is down. And then there is another flag called auto approve. So we have a workflow built in that allows you to say whether you want to approve changes or you want to auto approve changes and don't want to look at it, right? So for lower environments, you might want this true, but for higher environments like production, you might actually want to look at the changes and approve them for various reasons, and then kind of deploy it. So what I'm going to do is I'm going to set auto approve to false, and then I'm going to also set teardown to false because I want to actually provision the environment. Okay. So now again, this is GitOps based. I'm going to push to main directly, but you kind of get, right? I can create a pull request here. Someone can review the change, see what changes it's going to apply, and then actually merge it. So here's the diff, right? Just making two changes. I'm going to add and commit and say provision my prod blue environment. So once this is pushed, right, or a PR is merged, the changes will get picked up. Now, if I go back, it takes about 30 seconds for it to pick up. So what it's going to do is it's watching the GitHub repo, same as if you look at Argo CD or other tools, right? They watch Git repositories. Any changes that happen, they pick it up and then deploy it. So see how it just started is picked up, right? What I did is I said the environment is totally destroyed, right? I want to provision it. I made two lines of change. One is actually set teardown to false because I want to provision it. And then I also said I want to actually approve some of the changes manually. So now, as you can see, it starts from the top, right? So it knows what order to run, right? Which is one of the challenges. In the example I was giving earlier, when you do this using some pipelining tool, you need to write which component to run first, right? All of these individually are running Terraform, right? And in some cases, Helm. And what that will do is they will have their own state, right? So all of these are individually managed separately. Their states are managed, so you don't have to build like a monolith Terraform to run everything. It promotes loose coupling, right? Because you can have these various pieces and then it's very easy to connect. So see, as you can see here, what it's doing is it's running plan for all these. And I'm gonna kind of click on this. So see, this is networking and it just ran the plan, right? So it's gonna show you what changes it's gonna make. In this case, it's gonna provision a bunch of resources. You can look at, this is your Terraform plan basically. And then if you go at the bottom, right, after all the changes, it gives you what it's going to change, right? So it is, this is just a big Terraform. Okay, so see, it also gives you summary. So here it says it's going to add 30 resources. It has all of this. It also gives you a monthly cost estimate. So you can see in this case, it's just $36.50. And then it gives you the breakdown. So in this case, networking was auto approve. So it automatically applied changes and it's actually, initializing the apply and it'll start applying the changes. In the case of static assets, which is just an S3 bucket, we want to actually manually approve the changes, right? So this is the flow where you can check the plan. You can see what it's going to do. If everything looks good, you're going to approve it. So once you approve, it's going to apply. So just to answer your question, what's the workflow? It is a GitOps based flow. You push your changes. CloudKnit monitors those GitHub repositories where you have your configuration. You can have a mono repo. You can split it into multiple repos. And we will watch them. And as those changes get picked up, we kind of make sure that we run those components in the right order. So in case of provisioning, it starts from the top. And I'm going to, in a few minutes, also show you how you can tear down an existing environment. But I'm going to pause and see if you have any questions or comments.
Yes, I think the absolute the flow looks wonderfully well because one thing you showed is as commit to via GitOps because everybody want to have a drift detection is in place because that's the beauty of the GitOps workflow. You actually did some changes in your flow and the GitOps controller look at, oh, the actual state is not much actually not matching with the desired state. Lets me do my job best to make everything async. So that's a great workflow to work with. The next question is if the developers are working currently and they want to spin up EC2 instance and then they want to spin up Kubernetes cluster and then they want to add third-party application on top of Kubernetes cluster. So are they actually having the same Git repository or that this Git repository is managed by platform team and this will live separate or it's alongside the dev repository of the application?
So it's up to you. If you have a separate platform team that manages the base layer, right, up to your Kubernetes cluster and maybe some basic Kubernetes apps, and then app devs actually deploy. So I'm going to show you an example while this is running. So here's an example, an environment which is Bootstrap environment. So we have an environment called Bootstrap that we dog food ourselves to deploy CloudKnit. So if you go to this, right, so we have three environments, dev, play, and prod. This is the dev environment. In the dev environment, what we have is we broke down dev environment into multiple smaller environments. So let's look at this dev common, right? So if I go to dev common, this is my base layer, which has networking, which has EKS, and it has a couple of other common things like we use Argo workflow, we have a database that we use, and then there are multiple common apps that we deploy. all of this is managed and could be managed by a central team, like a platform team, right? But now that you have the base layer, I want to deploy my apps. And that is where the next layer comes in, which is my tenant here, right? So here, if you can see, I have some org level stuff. I have my other apps here. It's failing for because the state is locked. But either way, what this is, right? This is something that could be managed by app devs, where they have a bunch of apps that get deployed on top of my base, which is the common. And then I have some other things. So you can easily kind of break a complex environment and say, like, okay, all the base layer managed by a different team lives in a different repo if you want, or it could be the same repo, different folder, whatever you choose to do. But then app devs can have their configuration in their repository. So you can break that. It's still dev environment, right? And you can have multiple teams use the same cluster, right, with different name spacing and all that stuff. And they all will have their own sub environment within the same dev environment, if that makes sense.
Yes, and one question on top of this, like if let's say we have a dev staging at a production environment, and in the dev environment, some team are using EC2 machine, RDS, and AWS Lambda plus Kubernetes, and in the dev environment, like is it possible to tell like this is a component that the developer is using, and this is the component is the app dev is using, and this is a component that the security and compliance is using. Is that a breakdown available as of today?
So you can do that in various ways. So one is, again, you can have these layers, right, built in, which allows you to group things, right? So within dev, you can group and create those separate components. So here's the payment environment. What you can do is, or actually, let me go here, right? So what you can do is you can have various owners here, and you can add custom labels, right? So you can say like, hey, this is owned by platform team or app team A. This is owned by security team. If within a sub environment, let's say networking is owned by networking team, EKS is owned by some other team, you can add labeling. We don't show it yet, but yeah, that's possible to add it so that we can show, actually right here, team name is in this case is dev, but yeah, you can add custom labels and say who's the owner. So one label could be ownership, and then you can say like, okay, it's owned by security team or networking team. There are labels you can use in a way that allows you to specify who's the owner.
Oh, got it. Absolutely. And so let's just if somebody is using let's say, the microservices architecture, and the
Yeah.
microservices as requirement, your microservices are actually deployed on different, like some services on ECS, some on
Yeah.
EKS, some on GKE, and some on a lot of digital automation might be. And is
Yeah.
there a way like that's a breakdown of different cloud, the multi-cloud layers plus interaction? Is it how this flow works in the cloud net?
So that's a very good, yeah. So like people, a lot of companies are multi-cloud, right? So let's say this environment, I might have my database in Azure for whatever reason, right? Because it's a huge database or whatever. And I might have some other components in other cloud. So yes, you can mix and match and build. The idea is we are built on top of all these cloud providers and Kubernetes cluster. And then yeah, you can mix and match, and you can say like, you can mix and match technologies, automation technologies, mix and match cloud providers as well. Now, today, by default, we only support AWS. But again, like this layer is cloud agnostic. So you can easily mix and match different cloud providers. Tomorrow, if I mean, we definitely don't support DigitalOcean today, but if you want to, there are Terraform providers, Pulumi providers, and once you get a Kubernetes cluster there, you can use Helm. So yeah, you can easily mix and match, and you can get a multi-cloud environment using CloudKnit, and that's the idea. And in future, we are gonna also like show you where it resides, right? So this would have an AWS icon and this AWS, and let's say this is Azure, so you can kind of see how the whole environment looks and where it spans.
Yes, absolutely. That's make perfect sense here because basically you are using Terraform, Pulumi, that people are already using it, and
Yes.
using those, you can actually use infrastructure in Azure, AWS, GCP, and DigitalOcean everywhere. So basically,
Yeah.
the lower layer is already doing this job. So you are providing the upper features like centralized visibility, a DevX, self-service infrastructure platform, GitOps tooling for all those
Yeah.
environments. So making sure like all the people can see how the services interact and how the dependency tree gonna look like and how the interaction flows. So another question I think might be people asking here is, let's say if some of the services is broken more often than others, and I want to track those is, let's say I want to see networking is broken after 10 minutes and I see in a day it's broke 20 times. Is there a
Hmm.
capability like you can give them a, like I said, the observability features is not
Yeah.
specific to the CloudKnit, but now we're actually tracking down some of the services. So if that is actually, people might think like how do actually can enhance the developer experience with observability and troubleshooting.
Yeah, yeah. So that's a good point. So CloudKnit is the main goal of CloudKnit is allow you to provision, tear down. So it's during an earlier stage. In production, once you deploy these things, we do drift detection from your Terraform or Pulumi or what have you. But if you want to actually have observability monitoring for your services, what we are looking to do in future is integrate your solutions, right? So let's say someone's using Datadog or New Relic or what have you for their observability. We would integrate that in CloudKnit, and you can basically click a link here, right? Or we also maybe show some basic information here saying that hey, if it is down or whatever one of the services, or if one of the components has some issues, but you can click on a link and it takes you to the dashboard of your solution, right? Whatever observability solution. So we would integrate with an observability solution rather than us implementing something. But what we would do is uh, get you directly to the dashboard that gives you information for this environment or this component. But that's a future feature. We don't have it right now.
Yes,
So just
absolutely.
one thing. Yeah. Yeah. So just one thing I wanted to add, what you mentioned earlier around, various teams and the responsibilities, and also like, multiple cloud or what have you. So one of the patterns that some of our customers use is, let's say they have a central team, right? That is a platform team. They would manage blueprints, some of the common Terraform modules or Pulumi modules or what have you. They are the ones that give you common stuff, including a blueprint for an environment. And I'm going to show you in a bit how that looks. But they do all of that, and then what app devs do is they consume that, right? So they app devs don't need to understand Terraform as much. I mean, even though if they want to they can, or any other under the hood stuff, unless they really want to. They will get out of the box templates or blueprints that they can just use and then deploy stuff. So one of the things I would like to show there is the builder we have, right? Now, if you see here, there are a bunch of blueprints here. I'm going to drag and drop one blueprint, right? And this is blueprint is built by a central team that kind of gets you some basic features. You can still make changes. So let's say I want to remove this and add RDS here, right? RDS is another Terraform module. You drag and drop, it gives you the basic manifest that we have. And then you can use this, create a pull request, and kind of go from there. So it is a drag and drop tool, but we don't do any UI magic. We still generate code that you can use and create pull requests. And then you'll see there are blanks here to be filled, right? Which you can do it through UI here, and you can call it, let's say, payment team, then demo environment, and it's going to fill in those blanks. And then you can specify where your Terraform variables are and stuff like that. So it's just an easier way to get started. But what I wanted to point out is, especially for bigger orgs where you have central teams, you can have those central teams manage these blueprints and Terraform modules or Pulumi modules or what have you. And they can be in control of things, and they can give access to app devs. And then app devs can self-serve environments without knowing all these other technologies under the hood.
Yes, absolutely. I think one of the use cases I can look into the graph is like if the developer is wanted to have the infrastructure spun up, they go into the environment builder, and then what they basically do is to actually drag out of it, and then they
Yeah,
basically what they do is actually fill in the environment variable, and then they
yeah,
merge a pull request. So basically what
absolutely.
happening is instead of asking a platform team to spin up EKS cluster with
Yeah,
having this thing installed, this much of secret control or this much of the GitOps controller. So basically what this environment builder does is actually they create clusters, they create environments by making a
yes,
pull request, and then the app team, the platform team, look at the pull request, and they see like compliance reason, like is this the variable names are correctly to we can merge it, and the basically it's a very simpler flow now. So app developers have the full control of the environment, and the platform and teams are actually making governance and consistency around
yeah.
environment, making sure that the names are set appropriately and the fields are set appropriately, not much too much of the consumption around the CPU RAM, and they can look at the parameters of the RAM. So that looks very, very reasonable as well. So that's a
Yeah,
great
and you
feature.
can, yeah, like some of our customers also run tests. So let's say you basically have you can run tests against blueprints, but you can also run tests against an environment that you're provisioning. So you can use any of the testing frameworks, right? And write some tests, well, either after the environment is provisioned, and then you can run those tests in your when you merge the pull request, and it runs a pipeline and just runs the tests. So it can validate those things and let you know if something fails. Yeah. So just one more thing. So coming back to the environment that we started provisioning, right? See, all of these components are provisioned. RDS is actually applying. RDS takes time. It's going to take 15-20 minutes. But you can see that EKS is waiting for approval. So if I click on it, see, it shows you the estimated cost. It shows you the breakdown of all of these. And then what I'm going to do, everything looks good. I'm going to approve it. And once I approve, it's going to start applying the changes. But you can see the flow here. The flow is basically allowing you to control. Now, right now, we have approvals based on plan. But in future, what we are looking to do is make approvals a little more smarter. So for example, approve anything that costs less than $1,000. Anything above $1,000, you need approval from someone who's managing costs in your team, right? Or maybe a central team. So it gives you better controls of when to approve stuff automatically, and at certain points, if you need better control on those rules, you can have those. So yeah, that's basically a provisioning flow. Would you like to see how you can tear down an existing environment?
Yes, that would be a wonderful.
Yeah, so here's another environment, right? Prod green. What I'm going to do is bring down the whole environment, right? Because let's say, and some of our customers, what they do is they spin up an environment at 9 o'clock when they come to office, and they tear down at 5 o'clock when we go, and it's scheduled, right? So basically, every morning they come, they have an environment ready. Every evening they leave, the environment comes down. So you're not paying for all these resources overnight or weekends when you don't use it. So let me go there. So if I go there and say prod green, right? Again, I am doing this manually just to show, but you can schedule this, right? Like you can schedule it using whatever your a simple commit basically. So I'm going to do tear down true in this case because I want to tear down the whole thing. I'm going to set auto approve to true because I don't want to approve destroy. It's an environment I want to just bring down. So I'm going to make those changes. So here's the diff. I'm tearing it down, and auto approve is true. And what I'm going to do is I'm going to say tear down prod green environment. Okay. And I'm going to push this change. Again, you can see like you can create a PR if you need to, or if it's a lower environment, automatic commits. Once you do that, it's going to, again, we are watching the changes, and shortly it'll start tearing this down. And when it starts tearing it down, it'll start from the bottom, because obviously you want to tear down the leaf resources first, or components, and then go up the chain. So we'll just give it a few more seconds, and it should start
Yes.
tearing it down.
Yes. So one question on this, like before when this is happening in the background, can you go
Yeah.
back into the code and talk about like I think you're using CRDs in Kubernetes, Kubernetes CRDs to is it
Yes.
so basically I'm
I'm
seeing like it's yes.
Yeah, yeah. Let me just open this. Hold on, just give me 1 second. I'm closing these windows, and I'm gonna open uh the file and show you. Okay, open.
Yeah, so there's a basic question here, like is it as any CRD the user of the CloudKnit managed to learn or have to updation or upgradation on their behalf?
So that's a good point, right? Like, why do I learn this new thing? So what we say is, and this is just coming up. Okay, so what we say is, it is something that, yes, it's a format. It's a you can see this in YAML. It's a CloudKnit custom resource definition that allows you to do this. It is simple, but yes, it is something that people need to understand. And that's why we have things like drag and drop that makes so that you don't have to write the whole thing, right? You get a starting point, you make some changes. But in general, this is a typical CRD format, right? At the top. And then you have a few variables, which is what is the team name, which is the environment name, Teardown and auto approve, which we have used. And then you get down to components, right? So in this case, networking, we are using Terraform. So you can see here's the VPC module. Here's my Terraform variables, right? So if I go to variables and look at networking, here are my variables, right? And then if I go back there, here are the outputs. And then if I go to the EKS module, again, it has some basic stuff where the module is, but then that depends on networking, right? So yeah, to answer your question, yes, they need to understand this YAML, but if you use blueprints or if you use the drag and drop builder, you don't need to know this in and out. You once you build it, you might want to change a few things, and in most cases, you might want to change a TFVAR file. But yeah, so
Yes, and I think like, this is only one CRD that you're actually introducing. So any resource that will become a part of this chart, so basically the only one CRD that is
yeah,
actually doing all this heavy lifting, not tens or hundred of CRDs. So basically one
absolutely,
CRD introduces to add all these kind of stuff. So meaning a very bare minimum of learning curve for you. So if you're actually
absolutely.
already knowing YAML, this is not, I mean, a learning curve for you. You actually already know this, how the YAML works. We actually just need to understand the construct and the structure of this CRD. And then the one CRD will give you all these kind of functionality. So that's a very, very great model, to be honest. Great work.
Yeah, thank you. Yeah, so absolutely, because we didn't want to introduce, like, hey, and I've seen, like, other ways of doing where you have to write like 20 YAMLs to get an environment, and that just becomes very difficult to troubleshoot, understand. And yeah, so that's why we wanted to keep that minimum. And then again, like, you can have a central team control some of these things already. So to an app dev team, they don't even need to worry about anything under the hood. They might want to understand the YAML a little bit just to make sure that they can make changes, but they will already have all these blueprints built in, right? That's taken care of by someone else. So just for a second, coming back to this environment that we started tearing down 3 minutes ago. So as you can see, right, EC2 is destroyed. It's a leaf node. This is destroyed. Once this was destroyed, it started running plan for EKS. It's already applying RDS, right? Again, RDS will take whatever time it takes to destroy. But once it's destroyed, it's going to go here. It's destroying SageMaker. So yeah, like within less than 10 minutes, a complex environment like this will come down. And that that is basically, you can do that as many times, right? So you can spin it up in the morning, spin it down in the evening, and stop paying for all these complex resources, and save thousands of dollars, if that's what your goal is.
Yes, I think that's a very killer feature of this open source tool is that like when you spin up the infrastructure, this tell you how much it's cost upfront because a
Yeah,
lot of the tools are lacking. If you do this doing manually using Terraform, there's no way for you to calculate those prices unless you have a fancy tool to do it. So if that fancy
yeah,
tool is doing you all these things, but they're missing this dependency tree and tuning down and scheduling of tearing down and spinning up infrastructure, and you can actually schedule base infrastructure and schedule based tear downs plus estimated cost. So I think that's three, four features are really shiner. And I think not one of the viewers or listening or watching to us, they disagree. Like they say like, I don't want this. I think there's no one actually saying like this. I don't want to see a cost up front. So that's a killer feature we have. That's great thing. So I think like the one question like the people are watching it, the tearing down is happening, and
yeah,
the application is deployed on top of it. So what
yeah.
happened to those applications? Is it they actually break down first and then infrastructure, or is it the in asynchronous steps up happening behind the scene?
Yeah, so this EKS add-ons uh, could be your Helm chart, right? That deploys the app. So it'll actually delete the apps first and then destroy the EKS cluster. So, like I said, we deploy CloudKnit using CloudKnit, right? These are some of our apps that we deploy on top of EKS. So, yes, when we run it, so we use Helm under the hood, but still use Terraform to call Helm, right? We are adding native support for Helm. So basically, you don't even need to specify Terraform for that. You can just specify, but yeah, it'll take care of deleting the apps as well. And it'll do it first before it destroys the cluster. So yeah,
That's a very unique.
yeah. Just one more thing that you mentioned, I want to kind of cover. You mentioned the cost, and again, like we under the hood we use infra cost to do this, right? And there are tools who provide you this cost estimate, but what we do differently compared to other tools is that we show you the cost not just at the component level, at individual Terraform level, but also the cost for your entire environment. Again, estimated cost, so it's not real time cost, but it gives you an estimated cost, but for your entire environment, right? And getting that value, and even maybe going up, and in future we are looking to add dashboards and reports, right? So one of the dashboard we have right now, which is a very simple, shows you various teams, their environments. So for example, here's prod blue, here's EKS. So if I click on it, it's applying. So I can kind of see all my environments, all my components color coded with various statuses in one view. And then in future we are looking to add more reports. The reports will tell you like, hey, give me a trend of cost for my various environments for the last 1 year, and it'll give you how is it trending upwards or downwards, and what changes are happening for my cost. Another question you could ask is like, which teams are doing machine learning in which cloud provider? Getting those answers through dashboards and reports would be a lot easier. We don't have those dashboards yet or reports yet, but that's something coming. We have the data because we you are provisioning your environment using this, and you are saying which environments to provision and what components to use. We are going to make it available to you so you can run various reports.
Yes, absolutely. I think that's a super important because currently, right now, is not the hustle that people are not good at spinning up infrastructure. I think the hustle is spinning up infrastructure in a low cost, efficient manner. Like it's a
Yeah,
very less cost to you, and there's a solution available as of today that help you bring down the cost. And there are some good patterns available in the cloud market as well. But having those visibility is very difficult. You can do and you can do mistakes, and there's no one to notify you. Having a visibility like reports, and it's also help teams to uh, KPIs as well. Like how do you actually understand how the team is actually working and how their solutions and how their infrastructure is actually working efficiently. So having those things built in, I think has give a lot of value to app team plus the platform team as well. Having thus, oh, why this infrastructure spend comes up $1,000, but prior just a $10, what's happening in just 2 weeks? So actually not going into the battle around what's go wrong is
Yeah.
actually is going is tell you before the things get wrong. So that is a analogy here. So that's a very good thing. So before I let you go, you give us wonderful intro of all the things that there. What next is planning up? Because I think
Yeah.
there's a lot. And then there are some questions people have in their mind, like they want to extend CloudKnit for their own specific need because they think like CloudKnit is a upper layer and they're using service on top of it. One of the things we talk about like observability and monitoring tool, and
Yeah.
some one of the things like you use ingress controller from the cloud or load balancer from the cloud, and then they give you a lot of cost, and people want to have some opinion why where we how we can switch to the open source platform like using this control like nginx or other open source tooling. How do we all these integration can embed in the cloud net, because this is totally an open source project.
Yeah. So, couple of different ways. So, we do have plan a roadmap, and I can share with you later like a list of things. But basically, adding support, native support for some of the things like Helm, some other languages, but also like other cloud providers is coming up. We are basically doing it based on the needs of our customers or open source users. So, if you have any feature that you want to contribute to, yes, you can definitely you can reach out to us, right, and contact at cloudknit.io, or you can create an issue here in the GitHub repo, and we can interact through that. In terms of one of the things you mentioned earlier, which I want to cover is, and which answers your question about adding features on top, is that how do you actually use this open source project, right? Few different ways. So one is you can deploy this yourself to your cloud provider, and we would even help you, right, to get you set up and get used to using it. um, the other option is what we do for some customers is basically use our SaaS offering to deploy CloudKnit to your cloud provider, right? So think about this, and which is what we show it here, right? Bootstrap environment. So this bootstrap environment, we are using the deploying the dev, play, and prod CloudKnit setups in different cloud environments, right? In different AWS accounts. So you can use that. You can use the SaaS offering to deploy the open source solution to your cloud, right? It could be AWS and in future other cloud providers as well. And once you do that, you have this open source solution deployed on your end, and you can have whatever URL you want and stuff like that. And we are going to make it really easy, where you will have a button here and you can just click on it and say deploy my open source deploy this open source solution to my cloud. We are working on it, but until then, if you are interested in that, we are happy to help you with that. Now, after that, if you want to make changes, right? So let's say I want to integrate my other tool, like let's say Datadog or whatever tooling on top of this. Yeah, that's when you can either contribute to this repository, or fork this and have add features on top of this, and then deploy that either using our SaaS solution, or you can deploy it on your own, right? These are all these are all Helm charts that you can use to deploy these apps. And then we have Terraform as well, which again, if you're interested, reach out and we'll give you access to it. We're going to open source it, or open source the Terraform that deploys this as well. But until then, you can reach out to us and we'll definitely give you access and help you even deploy this open source solution.
Yes,
Hopefully that
absolutely,
answers
absolutely.
your
Thank you
question.
very
Yeah.
much for wonderful insight, others, for all. Yes, absolutely, truly. Because I think right now what the focus is like having, I think one of the feature I really like about like we have a dependency tree and then the application is deployed on top of the infrastructure, and that visibility tells you how the infrastructure is actually dependent on other layers. Having a visibility of monitoring observability like tools like Grafana and Prometheus is give you the whole insight. Like your application deployed on EKS cluster and EKS using this side of networking, this side of let's say storage, this side of RDS instance, your application deploy, you click on it, you can see the matrix of application and infrastructure, and that's a heaven feature for application and developer team as well. So application team spun up the infrastructure using an environment builder and then having a click of visibility of Prometheus or Grafana, and then the platform team look at the chart board of how the application and infrastructure works, and then they basically what they do, they ask the development team, you spin up the infrastructure, there's one variable, and the way you actually spin up is causing a lot of the cost. Let's spin up another Terraform, let's spin up another module to save some cost and make a GitHub, make a Git commit, and then your infrastructure spit up again. And this infrastructure is actually a low cost effective, and it is having a very low cost associated with it. So I think that's a very heavenly, but that's you as you mentioned, like there's various way to work and actually contribute to the open source platform. But thank you very much, Atarsh. We're top of the hour with very less amount. We covered a lot of the great feature. I think there's a not a reason why people do not learn it locally and spending time to understand what it actually has to offer, because there's some very unique feature you don't see in other places as well, like the cost breakdown, visibility, and how to spin up. These are the very good way to interact it. So without any further delay, how people will find you on the internet if you want to learn more about CloudKnit, and how people will find you on the conferences if they live closer to New York.
Yeah. I mean, you can find me on Twitter. I'll give you my Twitter handle. It's my last name, my first name is my Twitter handle. And also, yeah, I mean, you can always reach out to me via email. It's my first name, Adarsh at cloudknit.io. And yeah, I'm based in New York. So usually try to go to local conferences, either speaking or even organizing. So yeah, would love to see people around here. And yeah, reach out to me. I mean, you can always find other ways to reach out on Slack, uh, multiple Slacks I'm part of. But yeah, if you need to reach out, I'm sure you can find me. I think you're muted. No.
Thank you very much. It's been a great learning session, but a very small amount of time. It's make me very excited about learning this tool in the near future. Try to spend some time, learn about it, and tell people others, and follow others on the Twitter handle as well. That's there's place to go about it. And if you want to see the solution, here's the cloudnet.io website. You can follow the CloudNet Twitter handle that's available on the screen now. Here's the GitHub repository to learn all about things. And one thing I can tell you, there's some wonderful blog post on the cloudnet.io website, and some are very generic related to platform engineering concept around challenges and solution. Go explore it on your own and let us know how you feel about it. With that, I'm thank you very much for Adarsh. It's been a pleasure talking to you. Back to back episode with you. Learned a lot. Learned wonderful ways around understanding the platform and the service infrastructure challenges. So, with next episode, guys, we will be talking about developer relations, developer advocacy, open source, and how to structure your platform team on top of your platform engineering stack with my guest from team Romario, and he's from Octato. And we will be going live on the how to structure and align your organization on the platform engineering stack. With stay focused and stay learning. Have a wonderful day, everyone. Stay safe, stay healthy. Bye bye. We'll meet again soon. And thank you very much for listening to us today on this episode.